Okay, this is another double integral. This time we've been asked to find the double integral of this generic f of xy over this shaded triangular region here, given by the functions, and we're asked to set it up both ways, x first and y first. We're going to do x first to begin with. So as an x first integral, we want to go from x equals something on the left over to x equals something on the right. So we have that as our rectangle or our slab. We want it to be in terms of x. So this is from x equals y on the left to x equals 2y on the right. And you see when we do x first, we might have to rearrange our functions to be x in terms of y instead of y as a function of x, which is what we did here. X equals 2y. So we have our x first integral. We go in from x equals 2y up to x equals y of the function we're integrating, dx, and then the dy, we're thinking of just a bunch of these rectangular pieces all the way down here from y equals 0 all the way until we get up to y equals 2. So we go 0 to 2. That's the integral as an x first integral. Now if we consider it as a y first integral, we see why this matters, right? We see why we care about x first and y first in this example, because if we do it as a y first example, then we want to go from y equals something down below up to y equals something else up above. But we see that right here, the nature of what's down below and what's up above changes, right? Over here, we have y equals x over 2 up to y equals x. But in this region here, we have y equals x over 2 going all up to y equals 2. And so we have to split the integral up into two integrals, and we have to do it as an integral from y equals x over 2 up to y equals x. That integral goes from x equals 0 to 2 of f of xy dy dx. And then we need another integral. We need another double integral for the rest of it, from x going from 2 to 4. Y goes from x over 2 up to 2 of f of xy dy dx. So it really requires two double integrals to do it if we want to do it y first. Because of the nature of the region, you can't just go from a single function y equals x down below to a single function y equals x up above. The nature of which function is down below and up above changes at this dotted line here, and so you have to split the region up into two separate double integrals, and it's just twice as much work, where if we do it x first, it's just a single double integral to do, and it's a lot smoother and easier.